So for EDS on our SEM system in the middle, SEM EDS suite, what we're going to do is open up the Phenom Pro Suite software, which is right here. Double click on it and this page should pop up. Click the Elemental Identification tab, and actually same image is already here, but let me go ahead and reload it. To load an image on here that you want to do EDS on, just go ahead and hit the reload button in the top right corner. There we go. There's a couple errors which popped up, but they were inevitably irrelevant. I had an earlier image from a previous test I did with this, but we'll go ahead and focus on this one. You have a couple options for elemental identification with EDS here. First, you can do point analyses, pick a couple points, and get an elemental breakdown there. This is some sort of organic that's sputtered in gold, so we're seeing primarily carbon and gold seen in the top right here. So these are point identifications. Then we can also do a entire sample identification. So the point identification will just indicate the elements of the points. The entire sample analysis will get the composition of the entire region. For the analysis tab, you will see a spectra corresponding to the characteristic fluorescences of whatever atoms are inside your sample. So if you have something obvious or glaringly incorrect inside your sample, so there's phosphorus here, for example, which may or may not be there, but you can go ahead and cross out unlikely candidates by doing this. Just right-clicking, and we'll take out yttrium as well. So you can also specifically look for something by holding right-click on it, I believe. Oh, that would really cross it up, okay. Yeah, we can hold right-click on it for an extended period of time, and it will look for it and try to fit to it. So, tried to look for nitrogen, kind of found something. We're going to deselect it. So that is your analysis and your acquisition tab. The final portion of EDS that we have available are mapping features that you can do with EDS. So what that would entail is either selecting a line mapping of a region, so doing something really simple like this. Let's go ahead and bring this down a fair bit in terms of resolution and pixel time and everything like that. Just since this is a demo, we don't really need a high resolution or good analysis, but you can do a line. We'll do an analysis along that region, and we'll show you what's going on there. So it shows you the changes in concentration across that region. Go ahead and go back to our image. So yeah, there's some screens here which indicate that, and then also you can do an elemental. That was another full image mapping that I just selected. This is a really unrefined mapping, but it's all right, it'll work. Then you can also do a specific region, which you can indicate by clicking that second button and highlighting over a region and getting that mapped. So go ahead and cancel this one. So I'm not all that interested in it. You know what? It'll run. So go ahead and this should finish itself up. The thing to note here is that this is a really low quality sample, or really low quality imaging. So what you can do here is you can increase your map resolution and your pixel time to make the pixels smaller and increase the resolution of your sample region, yielding a better EDS mapping. And to note, each of the pixels corresponds to a different element. So now I'm doing the 7th mapping here. This should start momentarily. So now it's going to do mapping over the very specific region which I've indicated. And once again, the resolution is a little bit better because it's a smaller region. But you can bump that up by messing with these features here. And you'll see the estimated time for your set mapping, and it'll be indicated to you. So this is boron's popping up, and I'll cross that off because I think that might be unlikely. Those are the main things to note with EDS. If you are setting up EDS with a sample, it's best to make sure that you set up a high voltage for your mapping, as to acquire the wide variety of energies you can get for your characteristic fluorescences of your elements, and to make sure that your beam intensity is set for something appropriate like mapping or point analysis. That's it. Thank you.